Hello everybody, today I want to introduce you to the new version of TerraTorch Iterate version 0.3, and the coolest new feature in my opinion is that you can now run and optimize over arbitrary code. So the only thing what you have to provide is a script, so a Python script or any shell script basically. And it's a relatively simple thing what you need to do. Let me just walk you through the steps, and then you can optimize anything either on your local machine, on a GPU cluster, using workload managers like LSF or Slurm, OpenShift, PBS. But yeah, let's have a look how this works, okay? So what I'm gonna do is I'm creating a folder somewhere where I have space. For example here. So let me copy this command. And I cd into this folder, and I'm creating an environment. Let's do this here. Okay. .venv. So now it's done. Now we should be able to call iterate. And we are presented with all the options, but don't get overwhelmed. Don't get overwhelmed. By the way, if you are a user of TerraTorch 0.2.3 and older, the new so the command is still there. It's just called Iterate Classic, and we will gradually re-enable the old Iterate Classic functions in the new iterate command. Okay, so let's do one local execution. So before we do that, we need to get two files, and let me show you those two files. So this file is basically nothing else than a script which executes. It takes three parameters, x, y, and z, and it will write a metric to standard out. And that's how you interface with iterate. You have a script which takes a set of hyperparameters, which are defined here, for example, and then you just write out the metrics to standard out, and that's how we grab it, and we then give it to Optuna, basically. No, so that's one file, and the other file is this here. So that's the HBO config, and what you see here is those are static parameters you just pass over to the script. And then those are the hyperparameters where Optuna chooses a range. For example, standard is using Bayesian optimization. It will choose the next probable range of values, the next probable set of values based on the Bayesian model, which is trained in the background as well. Okay, so now let's just execute it. So this is this command here. So it's iterate, and then let me increase the size a bit. It's iterate, and then the actual script you are optimizing over. Then the root here, that's the optional parameter. And now you see here all the Optuna parameters start with Optuna. So Optuna has the concept of a study name, and it has also a SQLite path where all the experiment data is stored in. And then we need to pass the static and the HBO parameters to the script. And then the workload manager is none. In this case, we will use LSF later. And then we tell also iterate that it should grab the Y-well from standard out, which we store the actual metric in. Okay, so let's run this. Okay, and now you see it's relatively fast. Now one experiment is super fast because it's just a little function, and then after 100 runs, it tells you that trial number 93 is the best, gave you the best result. So now actually run it using LSF. So you see here, all the parameters are basically the same. The only thing what we change is that we set the workload manager to LSF instead of none. And another thing is the default value for GPU count is 1 in the case of LSF. So we override it with 0 because we don't need to waste the GPU for this bumpy function. By the way, the bumpy function is just a function with one global optima and a lot of local optimas. So it looks similar to the previous example, but what you see here is waiting for dispatch, and then it's saying starting job on. So let's stop this and let's scroll a bit back. So you see here it's saying waiting for dispatch and starting job on host name, and then job is finished. And that's basically the LSF job manager. You can also use Slurm, and we are currently implementing PBS and OpenShift as workload managers. And that means you write it once, and you can now then distribute the HPO and neural network architecture search workload on all your favorite clusters and HPC cluster managers. Okay, one last thing is there's a nice tool which Optuna brings. Now you say pip install Optuna dashboard, and then you just run this tool, and then you have a nice UI where you can track your experiments and also see how the hyperparameters are influencing your metric. Okay, so that's all for now. Have fun and let me know in the comments if you need something else or if you encounter any problems. Thank you. Bye.